Okay, let's do a short video on multiplying uh, rational expressions where it's just a monomial on the top and the bottom of the expressions. So rational expressions, and our form is going to be monomial over monomial times monomial over monomial. Remember, a monomial is just a single term of a polynomial. So let's look, for example, let's look at, say, x squared y over 2x yz, and then I've got x squared y squared z squared over x z cubed. Okay, so each one of these things doesn't have any additions or subtractions in it, right? It's just a single monomial. It's a single term polynomial. Okay, so essentially what we're going to do is we're going to try and count how many of each variable we have. If it's in the numerator, we add the count. If it's in the denominator, we take away the count, right? Exponents count things positively if they're in the numerator, and they count things negatively in the denominator. So we're just going to count how many x's, how many y's, and how many z's we have in this sort of an expression. We also have to deal with the numbers here. So I've got a 2 here, so the only new number that I have, well, I've got implicit 1s on everything, right? But I do have a 2 down in the denominator, so we'll leave a 2 in the denominator. Now I have to count how many x's that we have. I've got 2 there and 2 there, so there's 4 x's on top, and there's 2 x's on the bottom. So for a net total of x's, I've got 4 on top and the 2 on the bottom. 2 of them cancel. I'll be left with 2 on the top. Let's do the same thing with the y's. I've got a y and 2 y's. I've got 3 on top. I only have 1 on bottom, so I will have a net of 2 y's on the top. For the z's, I have 2 on the top there, but I have 4 on the bottom. So 2 on top and 4 on bottom means that there's 2 z's left over on the bottom after all the canceling happens, right? Okay, so I've got x squared y squared over 2z squared is the result of that monomial multiplication. Okay, let's do one with division that's similar. So let's go m n p. Let's put a 2 on that, and let's say I have 5 m squared p, and I'm going to divide this by, let's go with 15 n p, and let's say I've got 7 m squared n p squared. Okay, so division, we have to multiply by reciprocals again. So we're gonna flip in the multiply, and I'm gonna write just everything out after I've flipped and multiplied. So 2mnp, 5m squared p. I'm gonna multiply now after I flip, so 7 m squared n p squared, and I've got 15 n p. Okay, I have more numbers to deal with this time. So let's see if any of these things cancel. This is already in factored form, and the 7's already in factored form. The only thing that's not in factored form is this 15, and it would factor into a 3 and a 5. But I have neither 3's nor 5's in the numerator, so I wouldn't be able to cancel either those 3's or 5's in the numerator. So we're just going to have 14 over 75 when I put those numbers in, right? Nothing cancels with the numbers. 2 times 7 is 14, and 5 times 15 is 75. Okay, let's see how many m's we have. I've got 1 there and 2 there, so there's 3 m's on top and there's two m's on the bottom, so one of them is going to be left on the top, right? Those two guys cancel, I'm left with one m on top. Counting n's, I've got two n's on top and one on the bottom, so two n's on top and one on bottom leaves me with one on top. And with the p's, looks like the p's all cancel, right? I've got one p, three p's. Nope, they don't all cancel. I've got three p's on the top, I've got two p's on the bottom, so I have one p on the top. I don't have anything else on the bottom, no variables on the bottom, so let's rewrite this as 14 over 75 times m in p. Either of these, you can leave it as a fraction like this, or you can take the numerical bit out and write the algebraic bit by itself. This is probably more common in textbooks because this looks like a polynomial with this as the coefficient. So I would probably leave it like this, but either form is fine.